Okay everyone, so let's discuss about projectile motion. So the projectile motion is a two-dimensional motion between x and y axis. So the particle is moving in x and y axis both simultaneously. So this is the path of the projectile. This is the path that the projectile will follow. A particle of mass m and the gravity is acting downward. Okay, so this is a projectile motion. Now let's discuss the mathematics of this projectile motion. So here are two type of motions are taking place in case of projectile. One is along the x-axis. First motion is along the x-axis and other motion is along the y-axis. Is it clear? So the motion is along x-axis and y-axis. So these two motions are quite different from each other and we will see how. So let's see the motion along the x-axis. So the motion along the x-axis is a uniform motion. Why uniform? Because acceleration along the x direction is 0. So let's say if the velocity of the particle, initial velocity is u0, so this angle is theta, so the velocity along this direction will become ux, and velocity along this direction, y direction, will be uy, initial velocity in y direction, and ux is initial velocity in x direction. So velocity will be constant. Velocity will be how much? Every time it will be ux. Okay. Now if you are talking about the y-axis motion, the y-axis motion is under gravity. You can see the motion is under gravity. So in this case, initial velocity will be uy will be u naught sine theta. Here ux will be u0 cos theta. So see some of the parameters that define the projectile motion. So those parameters are what maximum height. So this value will be called maximum height. Along this initial to final point on the x-axis, this will be called maximum. This will be called the range of the projectile. So range, and it is maximum height. Okay. So let's see how to derive these two quantities, range and maximum height. Another thing is from here to here how much time it will take. So we have three parameters to decide here. We will work on three parameters here. Those parameters are h max, time of flight, how much time it will take, and range, how much is it going along the x-axis. Okay. So first, time of flight. Let's see how to calculate time of flight. Now for the time of flight, you can see when the particle is going upward at the top point in kinematics, when the particle is at the top point, its velocity, vertical velocity, will become 0. Okay. Once again, in kinematics, whenever the particle is at the maximum height, its vertical velocity will become 0. So here only component will become ux. So here uy will be 0. Okay. Okay, let's see now. Uy or vy, first equation of motion in y direction, vy equals uy plus ay into t. Okay, so vy will become 0. Uy is nothing but u0 sine theta, and since acceleration is it's under gravity, so g because of downward, so it will be time of ascent, means from here, from initial to the top, how much time it will take. So from that logic, ta will become u0 sine theta by g. So u0 sine theta by g. Similarly, if you are talking about time of flight, it will become double of that. Okay, because let's see, from here to here it is taking ta. So from here to here again it will take ta, going up and coming down same time. So it will become 2 u0 sine theta by g. So that is the formula for time of flight, 2 u0 sine theta by g. Now we can also remember this time of flight formula in terms of component. So 2 uy by g, this will be the effective formula that you can remember, 2 uy by g. Okay, it means that time of flight is only decided by vertical component of the projectile, not the horizontal component. Is it clear? Okay, so let's see the next one, that is how to calculate maximum height, h max. How to calculate maximum height? Now Again the particle is going upward with what velocity? U naught sine theta. At the top point velocity will become 0. So if you use, we need this height, how much height is going, right? H max. If you use third equation of motion, Vy square equals to Uy square plus 2ay into s. So here final velocity will become 0, square will become 0. So here it will become u naught square sine square theta minus 2g into h, and that is nothing but h max. So from this equation we will get the maximum value. So h max will come out to be u naught square sine square theta by 2g. Or again we can remember in terms, or we can remember it in terms of components. So h max will become uy square by 2g. Okay, you remember time of flight 2u by g, here uy square by 2g. Now, so maximum height of projectile, from here we can conclude that maximum height in case of a projectile, it only depends on vertical component. It's very obvious because why is it going upward? Because of the vertical component. So how much high, who will decide how much height will go? It will be decided by the vertical component only. Okay, now let's see third one. Third one is a range. Okay, let's see how to calculate range. Okay, now range is nothing but horizontal distance, how much the particle is moving horizontally during its whole entire flight. So this will be called a range. Okay, the movement is in, the net movement is along the x direction, and so which component will be responsible? Only the ux component, right? And we already know that along the x direction is 0. So how much range it will be? Range is distance. Distance is nothing but speed into time. Speed is ux and time is time of flight, tf. So speed ux will become u naught cos theta, and time of flight it is nothing but 2 u naught sine theta by g. 2 u naught sine theta by g. Okay, if you adjust it, it will become u naught square 2 sine theta cos theta. It will become sine 2 theta by g. Okay, you can remember the formula in this term. You can remember the formula in this term, or other formula will become in terms of component. It will be ux 2ux uy by g. Whichever is easier to you, you can remember it. But again, if you remember the component formula, it will be very easy to remember in terms of components only, not the whole value. Okay, so try to remember these in terms of these formulas in terms of components. For example, let's see one example from the projectile. Question says that initial velocity of a projectile is given 3i plus 4j. Initial velocity is given as 3i plus 4j meter per second. So find out time of flight, find out h max, and find out range. Okay, so you have all the formulas. You now here, if you remember the formulas in terms of ux, 3, uy is 4. So here ux is given 3, uy is given 4. So time of flight will be given by 2 uy by g, and h max will be given by, maximum height will be given by uy square by 2g, and then range will be given by 2ux uy by g. Range is decided by both the components together. Time of flight depends on the vertical component only. H max depends on the square of the vertical component. Okay, so that's it from my side. Thank you very much. We will see you in next video.